Okay, let's take a look here at the answer to number one. Number one is y equals 3 secant x plus 2. Remember, on a secant graph, we want to think about the graphing the cosine curve. So 3 cosine x plus 2. We're going to find the amplitude. The amplitude is 3. The period is 2 pi over b. Well, b is 1, so period is going to be 2 pi. The interval is going to be 2 pi divided by 4, which simplifies to pi over 2. This one, there's nothing in the parentheses, so there's no phase shift, and we're going to shift the curve up 2, so it makes our midline here um, up here at positive 2. Um, when I sketch in my points, because this is, if I'm thinking cosine, I'm going to start up at the highest point, which is 3. I'm going to go down through the midline, down 3 more, and then back up to the midline, and then the same thing. So I sketch in the dotted line, the cosine curve. Anywhere that it's 0, I'm going to have an asymptote. So I've got asymptotes here, here, and here, and here. Once I sketch that, then I can go ahead and draw in my secant curves. So my secant curves are here. And then if I go to the domain is going to be for all elements of x, such that x is an element of the real numbers. X is not equal to negative pi over 2, which I picked this asymptote. The distance between the asymptotes is pi, so it's plus pi k, and then k is an element of the integers. Our range is from negative infinity all the way up to negative 1. And then the union of that, we pick back up here at 5 all the way up to positive infinity. Okay, let's go ahead and take a look at number 2. Number 2 is y equals cosecant x plus 3. Remember, on cosecant, we're going to think that we're graphing the sine curve in order to make our curves. So our amplitude is 1, period is 2 pi, interval is 2 pi over 4, or pi halves. Again, no phase shift. Vertical shift, we're going up 3. So midline, we're moving it up 3. Since it's a sine curve here, we're going to start at the midline. We're going to go up, back down through the midline. Again, our asymptotes are passing through any point where it's 0 there, or where the curve's passing through the midline. Notice that our domain here, we're going to say it's for all x such that x is an element of the real number. X is not equal to pi times k, so I just use the y-axis. So this is one of my asymptotes, plus pi k. That's the distance between the asymptotes, where k is an element of the integers. The range is going from negative infinity all the way up to positive 2, and then we're picking back up at 4 and going to positive infinity on the range. Okay, let's go ahead and look at number 3. Number 3 is y equals tangent 2x plus 1. Remember, on the tangent curve, we have a stretch. The stretch is 1. That's the number in front. The period is just pi over b, which is pi over 2. The interval is going to be pi halves divided by 4, which is pi over 8. There's no phase shift, and we're going to shift the curve up 1. My new midline is up here at positive 1. Remember, on the tangent curve, it's disco right. So the curve's going to start in the middle. So because there's no shift, that's where I start on the midline. Because my stretch is 1, I'm going to go up 1 and down 1 here. So up to the right, down to the left. Notice here I graphed 3 full periods. My asymptotes are going to lie at negative pi fourths, 3 pi fourths, and so forth. So my domain is for all x such that x is an element of the real numbers. X is not equal to negative pi fourths, that's the asymptote I picked, plus pi halves k, where k is an element of the integers, and then our range is from negative infinity to positive infinity. Okay, let's look at number 4. Number 4 is y equals 2 cotangent 3x minus 4. On this one, the stretch is 2. This is, again, a cotangent curve, so it's a disco left. The period is going to be pi over b, which is pi thirds. The interval is pi twelfths. No phase shift. The vertical shift, we're shifting it down 4. So the domain here, we're going to have asymptotes at the y-axis, and then at negative pi thirds and at pi thirds. So I picked the y-axis, so x is not equal to pi thirds k, where k is an element of the integers, and the range then is from negative infinity to positive infinity. Again, notice my stretch here is 2, and I've got it bumped down 4. All right, here's number 5. Number 5, we've got y equals negative 3 tangent 4x minus 2. Notice that we have a negative in front. That makes it a reflection, which means normal tangent curve is disco right, so it's going to make it a disco left curve. The stretch is 3. The period is pi over 4, which is pi over b, pi fourths. Interval is going to end up being pi sixteenths. There's no phase shift. We're going to move it down 2, so my midline down here at negative 2. Again, it is a disco left because of the reflection. It has a stretch of 3, so I start here on the y-axis at my midline, and I'm going to go up 3. My domain here, I picked the asymptote at negative pi eighths, and again, I know that the next asymptote is going to be pi fourths away from that, so that's going to be x, an element of the real number, such that x is not equal to negative pi eighths plus pi fourths k, where k is an element of the integers. The range is from negative infinity all the way to positive infinity. Okay, here's number 6. Number 6 is negative 2 secant x plus pi halves in the parentheses. Remember, we want to think cosine. The negative in front makes it a reflection. So amplitude 2, period is 2 pi, interval pi over 2. Phase shift, we're going to set this equal to 0, so the phase shift is negative pi of halves, and we don't have a vertical shift. So on this one, again, we're going to shift it over to negative pi halves. That's going to be my new starting point. It is a reflection, so my cosine is going to start at my minimum point, which is down here at negative 2. And notice I sketched in my dotted line of my cosine curve. My asymptotes are going to lie at 2 pi, pi, 0, pi, and 2 pi. So my domain is x for all elements of x, such as x is an element of the real numbers. X is not equal to pi k, where k is an element of the integers. The range is going from negative infinity all the way up to negative 2, and then the union of that from 2 all the way up to positive infinity. Okay, here's number 7. Number 7 is y equals negative 4 cosecant x minus pi. So we want to think about this one being, number 1, a reflection, and then also the sine curve. We're going to sketch that in to help us draw our cosecant curves. The amplitude on this one's 4, period 2 pi. Interval is pi over 2. Our phase shift, we're shifting it over pi, so we're moving it over to pi. There's no vertical shift. The domain on this one, we're going from our asymptotes being at negative 2 pi, the y-axis, pi and 2 pi. So it's x is not equal to pi times k. The range goes from negative infinity all the way up to negative 4. The union of that from 4 all the way to positive infinity. So again, because this is a reflection, remember the sine curve is going to go down first as opposed to going up first. Okay, here's number 8. Number 8 is y equals negative 2 cotangent x plus pi halves. So in this one, it is a reflection of the cotangent. That's a stretch of 2. The period is going to be pi, interval pi over 4. Phase shift, we're going to shift it over negative pi halves, so that's going to move the asymptote over to negative pi halves. There is no vertical shift. The domain, again, with our asymptote being at negative pi halves, is going to be x is not equal to negative pi halves plus pi k, where k is an element of the integers. The range is from negative infinity to positive infinity. Remember, regular cotangent curve is a disco left, so that makes this a disco right with a stretch of 2. So we're, again, going up to the right, down to the left. So I've kind of graphed here 3 periods for that one. Okay, let's go ahead and take a look at number 9. Number 9 is y equals 3 secant 2x plus pi plus 1. And this one, again, you want to think cosine, so 3 cosine 2x plus pi plus 1. The amplitude is going to be 3. The period is going to be pi, so 2 pi over b. The interval then is going to be pi fourths. The phase shift, we're going to set what's in the parentheses equal to 0, so you end up getting negative pi halves for our phase shift. So we're going to move it over to negative pi halves, and then we're going to move it up 1. So here's my new origin there where the circle is. Notice since we're thinking cosine, we're going to start at the highest point, which is 3. It's going to go down. So I've sketched the dotted line of the cosine curve. Again, all the places where it crosses the midline, we're going to have asymptotes, which makes the domain for all elements of x such that x is element of the real numbers. X cannot be equal to, I picked negative pi fourths, which was right here, plus pi halves, that's the distance between each set of asymptotes, and plus, as I said, pi halves k. So k is an element of the integers. The range goes from negative infinity all the way up to negative 2, and then we pick back up as a union all the way back up here at 4, going to positive infinity. Okay, here's the last one, number 10. Number 10 is y equals 2 tangent 4x minus pi in the parentheses plus 2. Remember, tangent is disco right. Our stretch is going to be a stretch of 2. The period on this one's going to be pi over 4 because b is 4. The interval, that makes the interval pi 16ths. The phase shift, you're going to set 4x minus pi equal to 0. That gets you pi fourths for the phase shift. So notice we're shifting over pi fourths, and the vertical shift is up 2. So this is my new origin. We start on the origin on a tangent curve, so the stretch is 2. I'm going to go up 2 here, and I'm going to go down 2. That makes my asymptotes at pi eighths, and then from there every pi fourth. So I use this asymptote to write my domain x such that x is an element of the real numbers, where x is not equal to negative pi eighths plus pi fourths k. So every pi fourths is going to be an asymptote, where k is an element of the integers, and then the range goes from negative infinity to positive infinity.